Good morning. I thought today I would read to you out of the textbook. It's all about using models in science. And I think if you watch the news today or any day, you're going to see models used. Specifically, right now we see a lot of models about the coronavirus. We see a model of the virus itself. We see maps of where the virus is spreading. We see data charts, which are also models of, statistics and things like that about what's happening with the virus. So I thought I would just kind of tie that into what we've learned already. So here we are on page 230, 231, if you want to follow along. Excuse me. Models. What would you do without your heart? One of the most important muscles in your body. Worldwide, people are on donor lists patiently waiting for heart transplants because their hearts are not working properly. Today, doctors can diagnose and treat heart problems with help of models. A model is a representation of an object, a process, an event, or a system that is similar to the physical object or idea being studied. Models can be used to study things that are too big or too small, happen too quickly or too slowly, or are too dangerous or too expensive to study directly. However, some models can replace organs or bones in the body that are not functioning properly. And now we have 4 different types of models specifically for the heart. The first one is a magnetic resonance image, or MRI. This is a type of model created by using strong magnetic field and radio waves. MRI machines produce high resolution images of the body from a series of images of different types of layers of the heart. For example, an MRI model of the heart can allow cardiologists to diagnose heart disease or damage. To obtain a clear MRI, the patient must lie perfectly still. Even the beating of the heart can limit the ability of an MRI to capture clear images. A computer tomography, or CT scan, combines multiple X-ray images into a detailed 3D visual model of the structure of the body. Cardiologists use this type of model to diagnose malfunctioning heart or blocked arteries. A limitation of a CT scan is that some coronary heart disease, especially if they do not involve buildup of calcium, may not be detected by the scan. Sorry about that. An artificial heart is a physical model of a human heart that can pump blood throughout the whole body. For a patient with heart failure, a doctor might suggest temporarily replacing a heart with an artificial model while they wait for a transplant. Because of its size, the replacement heart is suitable for only about 50% of the male population and is stable for only about 2 years before it wears out. A cardiologist might use a physical model, this is kind of like a plastic model, of a heart to explain the diagnosis to a patient. The parts of a heart can be touched and manipulated to explain how the heart works and the location and any complications. However, the physical model does not function like a real heart and cannot be used to diagnose disease. All right, now we have maps as models. One way to think of a computer model, such as an MRI or CT scan, is a map. A map is a model that shows how locations are arranged in a space. A map can be a model of a small area, such as your street, or maps can be models of very large areas, such as a state, a country, or even the world. Biologists study maps to understand where different animal species live, how they interact, and how they migrate. Most animals travel in search of food, water, specific weather, or a place to mate. By placing small electronic tracking devices on migrating animals, biologists can create maps of their movements, such as the map of elephant movement in Figure 1 on page 231. These maps are models that help determine how animals survive, repeat the patterns of their life, and respond to environmental changes. Limitations of models. It is impossible to include all the details about an object or an idea in one model. A map of elephant migration does not tell you whether the elephant is eating, sleeping, or playing with other elephants. Scientists must consider the limitations of the models they use when drawing conclusions about animals' behavior. Excuse me. All models have limitations. When making decisions about a patient's diagnosis and treatment, a cardiologist must be aware of the information each type of model does and does not provide. CT scans and MRIs each provide different diagnostic information. A doctor needs to know what information is needed before choosing which model to use. Scientists and doctors consider the purpose and limitations of the models they use to ensure that they draw the most accurate conclusion possible. So do you remember the last time you used a model? Well, we've done it many times in class. We use models to show the ocean currents when you guys created those big maps. We use models from the GOES satellite, right? We use images from the satellite. Anytime you drew and labeled a picture in class, that is a model. When's the last time you used a model? Think about it. Did you draw a picture when describing something to your friend or your parents? Did you build a model? Did you build a structure to describe something? Those of you that did the Pringles Ring Challenge, you built a model, okay? So it's something that we do all the time. We just don't really think about it. Anyway, I will see you all on Friday during our scheduled class chat times. And there'll be something small for you to look at tomorrow. I hope you have a great day. Miss you a bunch. Bye.